So next, let's welcome Carl Gans. Carl is a data scientist at Evolent Health. He has been working with Shiny for several years, and his work has been presented at many conferences for statistical practice, RStudio conference, Saturday, USAR. And let's join Carl for an insightful session on ADA compliance in Shiny apps. So Carl, the floor is yours.
Thanks. Thanks everyone for coming today. I appreciate it, and thanks to everyone at ShinyConf for letting me talk. I was fortunate a little while back to get to work on a project where we were building Shiny apps, and ADA compliance was a funding requirement. And so we went through this whole process where a third party reviewed our apps, kind of told us all the things we did wrong from an ADA compliance perspective, and it was a very educational experience. And so I'm hoping to sort of encapsulate everything I learned there into this talk today. And so our agenda today, I'm going to kind of try to give a high-level overview of the goals and requirements that come with ADA compliance. I'm going to dive into some HTML snippets, go into the actual metadata that we use here to sort of explain to the screen reader and to the ADA tools what's going on. I'm going to make sure to use some Shiny specific examples as well. I'll hopefully give you some Shiny specific things to think about in terms of how to make your applications more accessible. And at the end, I'll quickly go over a package I'm trying to throw together to sort of make basic level Shiny applications easy to test and address some of the basic issues more easily. I'm Carl, as they said. I'm based here in Oakland, California. And I've been working with Shiny for a good 7 years now. I know this is a little bit of a funny way to think about it, but I think the best way to start thinking about ADA compliance is what are the senses that you need to interact with your application. Unless HTML and JavaScript make some major breakthroughs, we can sort of remove smell and taste from that for now. But I think thinking about how a person who maybe doesn't have perfect sight, a person who doesn't have perfect hearing, a person with limited capacity to use a mouse or keyboard with their hands, how are these people going to be able to use my application? And so I think, as you can imagine, sight is really the big one here. When we think about a Shiny UI, we're thinking about a graphical user interface for the most part, and so that's making a lot of assumptions about the person's ability to see the page. And so the ADA expectations here are really, for a person who can't see, they're going to need a third-party tool like NVDA or JAWS to read the content to them. And it's our job as developers to make sure that the appropriate metadata is there so that the screen reader says the right thing and navigates the page for them correctly. For people who are not necessarily blind but do not have perfect vision, whether that's color blindness or you can imagine an older person who can't read small font, we have some obligation to make sure our apps are designed in a way that all these people can still see what they need to see and navigate the pages to the fullest, even with these limitations. And so that encapsulates a lot of requirements, things like minimum font size, color contrasts, and some other things that I will hopefully get into soon. For sound, for most Shiny applications, this isn't something we're going to have to worry about, but there are some expectations there that you're going to provide captions or a detailed transcript of any multimedia that's in your application for the screen reader. Touch is a really complicated one. Not every person is going to be using your application with a mouse and keyboard or be able to use a mouse and keyboard in the way that you really expect. And most of this requirements or expectations here as a developer are going to fall under making sure that all of the key elements of the page are tabbable. So, I'm sure everyone here at some point has used a form on a website and used the tab button to jump from one input to the next. For us, this is a nice convenience for people navigating with a screen reader or without a mouse. This is actually a real firm requirement to actually using the application. And so ensuring that you make all the important things on your page tab selectable is the main thing to think about here. So now, when we I'm sure many of you have gone through raw HTML code at some point in your life and seen aria dash this and aria dash that, and this is much many of the Shiny generating HTML generating functions are already including the necessary aria metadata, and so it's not something as developers we always have to explicitly specify, but it's good to sort of understand what some of these fields mean and understand how to use them in case you're working with a third-party package that's generating HTML and doesn't have the correct metadata, or because you're spinning something up from scratch yourself. It's good to have a basic understanding of what this aria metadata does. And so I've tried to split it into 3 categories that hopefully make sense. The main one's content, right? So perhaps working with Cordo or Shiny at some point in your life, you've added an alt text to an image. We all know this is sort of a good practice for a person who's accessing the page with a screen reader to, the screen reader's not going to know how to turn that image into a meaningful text. And so we need to provide some text for the screen reader to say here. For dynamic graphs that use SVGs, we might use something like an aria label or an aria description instead. But the idea is sort of the same. Sometimes we need to explicitly specify to the screen reader what to say here, because the object that we're trying to describe, whether it's a plot or an input or a table, may not have an obvious default thing for the screen reader to say. We also use aria metadata to describe statefulness. I will walk through this example a little bit later, but many times when you're on a page that has tabs, you can determine which tab is selected by looking at the page and kind of seeing which tab looks selected. And we might use a visual or even a color-based cue there to sort of signal to the user which tab is open. To a screen reader or to a person using a screen reader, this is not going to be obvious. And so we use aria metadata to sort of specify to the screen reader and to the user, these are the pages or the tabs that are open, and these are the ones that aren't open. And so maybe if I don't read the ones that aren't open right now. Similarly, we use aria metadata to specify functionality. If something is clickable, if something is selectable. Sometimes we have visual cues to indicate that. A hyperlink might have blue text so that if I click on that, it's going to do something versus a regular piece of text. But to a colorblind person or to a person using a screen reader, we're going to need some sort of metadata to indicate that this is not just regular text. This is something that has functionality. So here's a basic example. Getting into the content side. Plot output. If we run this outside of an application, just in a vacuum, it'll generate some HTML from us. And so I've cheated a little bit by adding this im object in the middle. In the actual application, just some JavaScript would insert this im object into the div container. But I'm just going to put this here so you can see what the actual rendered object would look like. You'll see there is a alt text field. This is our way of telling the screen reader, here's what the image represents. Here's what you read to the user when we tab to this object. Shiny does this by default. The render plot function has a alt parameter. We can dynamically populate this text, but if we leave it blank, it will give us this generic plot object message that I'll get into a little bit later about how we can be more as granular or as specific as we want with this content here. Now imagine another example. Suppose instead of using a regular static plot with an im object, imagine we're using Plotly or we're using gggraph or one of the other dynamic SVG bit-driven plotting libraries, maybe that will have by default the correct metadata, or maybe it won't. So it's good to know what that metadata is. And so in this case, this SVG that I've thrown together has no metadata. Screen reader isn't going to really know what to do here. So in this case, I've added the aria label field and an aria description field. There's not a huge difference. Aria label will display that text when you hover over the graphic with your mouse. You may or may not want that functionality, and so aria description can be better if you want to avoid the label hover. But both will be read by the screen reader once the graph is selected. If you wanted to dynamically apply this metadata, here's a little bit of a jQuery example of how to apply it. It's just using a jQuery selector to find an SVG inside of this ID, the container ID, and then adding the aria label, aria description, and tab index metadata, which I will get into in a little bit more detail in a moment. Another content example. So now we have two inputs. We have a base Shiny numeric input, and then I am pulling this custom numeric range input from the Shiny widget package. Here's what that might look like. We have, the regular numeric input at the top, but at the bottom, you'll see this is a slightly fancier input with really two inputs. For this first one, the default Shiny input does have the metadata that we need by default. You'll see that we have at the top this label element, and it has a for parameter with an ID as the value that points to the ID of the input below it. The ADA tools are smart enough here to put two and two together. They can see that the label is associated with the input because of this for pointing to the ID, and it will set the aria label to that value inside the label object automatically. So we don't have to go in here and manually specify an aria label. This will just work. For this second example, things are a little bit more complex. We have a label object, and it has a for parameter, but the ID of that for parameter is pointing to the div container. When someone with a screen reader navigates to these input objects, it's not going to know that this label is associated with both of them. It's going to think that these inputs have no labels because this label object isn't associated with them. And so one solution is to explicitly specify an aria label in these inputs. I can say this is the input to minimum, this is the input to maximum, and now when a user using a screen reader navigates to these inputs, the screen reader will give them a better, more detailed description for the individual fields. All right, that should cover the content examples. So I want to give everyone an example now with statefulness. You'll see here we have some simple Shiny code. It's just two tabs, one with a hello world and one with a plot. I'm not going to show all the code for that because it would be a lot, but this is just a little bit at the top with the two different hyperlinks that toggle the tabs. And so you'll see the top one has this aria selected equals true field. So this is what I was sort of alluding to earlier. We're sort of telling the screen reader which one of these is selected. Visually, this is obvious, but if you're just, the screen reader doesn't have eyes. The screen reader is just looking at the HTML document. It needs actual data in the HTML to know what should I read and what should I not read right now. I think it's also good to consider that this sort of statefulness is not just important for screen readers, but it's also important as a colorblind issue. In this example here, hopefully you can see in the top left, we have our two little tabs. And as a person with pretty good vision, I can sort of infer that currently tab 2 is selected. Tab 1 has blue text. That kind of tells me that there's some functionality there. If I click on the blue text, something will change. And so I sort of can infer from the color coding of these tabs that tab 2 is selected and that tab 1 has some functionality that if I click it, it'll open a new tab. Now I'm going to show you the same example, but on a grayscale. It is much less obvious which tab is selected in this example. Unfortunately, the tool that I used to put this in grayscale also highlighted tab 2. So this is not a good example. But in the real world, a person with severe color blindness who sees on a grayscale, if they encounter this application, they wouldn't get this square around tab 2. They would just see 2 gray tab 1 and tab 2s, and it would not be immediately obvious which one is selected. And so, we talked about in the case for a blind person, we have that aria selected metadata to specify which one is selected. But for a colorblind person, the approach here is really to try to use non-color based visual cues. And so I've added 2 little fixes here. One of them is a quick bit of CSS. I'm piggybacking on this active class to add this text decoration. Underlining is a visual cue that does not depend on color. And then for the actual bar chart, I'm going to piggyback on this GG pattern package to change the actual way it looks. So let me show you now. We're still in grayscale, but the 2 different tabs are distinct. One has an underline that sort of indicates that it's active, whereas the other one does not. And then the 3 different groups in the bar chart now are visually distinct, even though we do not have color. And so I know the ggplot community has been really good about providing colorblind friendly palettes, and that those are very helpful. But for people with severe colorblindness, that's still not going to be good enough. Patterns or just using non-color based visual cues is a really good way to get to provide functionality for potentially colorblind users. Now, one thing I had alluded to a little bit earlier was about tabability. So, for inputs, most browsers are pretty good about having tab support by default. But in general, the way you specify to the browser and to the ADA tools, the screen reader, what items are tabbable and which items are not, and the order in which they are tabbable is through this tab index metadata. You can apply this to pretty much anything on the HTML document, and you can then tab to it. If you set everything to 0, you will sort of defer that ordering to the browser. And for most use cases, that is fine. You may want to manually specify, this is the first thing to tab to, this is the second thing, this is the third thing. But for dynamically generated content and things like that, that would be a little bit tedious. So for a lot of use cases, just setting a tab index to 0 will get you a lot of the way. This little bit of jQuery very, very naively tries to take every sort of reasonably conceivable tabbable object, tables, plots, either whether they're SVG or images, inputs, buttons, hyperlinks. These are all things that have functionality. Or content, you're going to want your user to be able to tab to them. Is this too liberal? Is this going to probably make some things tabbable that you don't want tabbable? Maybe, but it's a decent jumping off point. This function won't be everything to everyone, but it can probably help cover tabability for some basic use cases. All right, so I alluded a little bit to Andy earlier because this was the tool that I used to create the image in grayscale. Andy is a tool generated by the government, as you can see here, that allows you to interactively debug ADA issues in your web application. And so by just adding this little tag script anywhere into your Shiny app, you can be able to run your Shiny application with this interactive Andy tool at the top that has these different modules for checking different things. So there's a color contrast module that I have open in this image. It allows you to set things to grayscale. It allows you to compare the color contrast between the text in the background, make sure it's compliant. If you have anything that isn't, it'll give you accessibility alerts on the right, and you can kind of go through and debug and try to manually update your application to fix the very specific issues that you have, whether it's specific colors that you've used that are clashing or things like that. It'll give it'll check font sizes. It really, you could probably do a whole 30-minute demo just showing people how to use Andy. I think it's a really useful tool to sort of pull into your application and just go ahead and debug these things directly. Some things to take away from this, from a Shiny perspective. One of the things that makes R and Shiny so cool is we have this like huge repository of third-party packages that have encapsulate all this awesome work that other people have done. But it is open source. Not everybody has the bandwidth or the resources to make all of their tools fully ADA compliant. And so whenever you're pulling in a new package or a new library that generates HTML, you do have to be careful. Is this generating HTML code that's fully up to ADA spec? Is it generating area labels? Is it providing an interface or a way for me to provide that content in the labels, or that's just something you always have to be careful about. Similarly, like I showed that Shiny widgets example where there, the ADA labels weren't quite right. People might use something like Shiny.js to add and remove classes dynamically to hide and show content dynamically in the UI. Whether or not the screen reader is going to honor that depends exactly on how it's implemented. I can't say necessarily whether it's right or wrong. I haven't checked, but things like that. And anytime you sort of spin up functionality outside of base Shiny, it's worth making sure that you're covering all your bases. Similarly, as I was saying, Andy is a really good tool for interactively checking all of these things. One thing about it is you are manually testing, and so it's really easy to miss specific interactions when you're doing that. So if I have like a drop-down menu, and when I hover over some text in that drop-down menu, it changes colors. I have to make sure every time I go into Andy and check things that I'm going into that drop-down menu and hovering and making sure that those colors are still correctly contrasted, or else my check is not exhaustive. So it's just very easy to overlook things when you're testing things manually. Another thing to consider is ADA does not necessarily have specifications on how detailed the content needs to be for an aria label or an alt text. As you kind of saw in that Shiny default, it'll just say a plot object. That's fine. I don't think necessarily for a person who's visually impaired who's trying to use your application, I don't know how helpful that's going to be to know that it's just a plot object. You might want to give them a better description than that. But depending on what kind of graph it is, you might actually be able to put into words a fairly good description of what it is dynamically. A simple bar chart like that, you could say, group A has a percentage of X, and group Y has a percentage of N. You can try and put these things into words for the end user, but you're not necessarily obligated to from an ADA compliance perspective. So I think that is one thing that from the Shiny community that we can sort of take a lead on is how can we make plots and tables more informative for the screen reader, not just a generic placeholder. Hey, this is a graph, or hey, this is a bar graph. But can we say, hey, this is a bar graph that says Group A has this value and Group B has that value? I mean, I understand for other types of charts, putting it into words might be very hard. In some ways, putting plots and tables into words is the job of the data scientist. It's that is the essence of our work in some ways. But finding the best way to do that, I think, is where the future of ADA compliance is. And then I guess the last thing I would say is, screen readers are third-party tools. Some of them people pay for, some of them are open source, and they're finicky. They don't all work the same way. Some of them have bugs in them, and you kind of have to do the best that you can to accommodate your users. What I would say is, test your app out with different screen readers, and do the best you can to make it work. And and if there are issues, try to reach out to those screen readers on GitHub and get those issues resolved. It's worth it for that community. And then lastly, I'm trying to put together the ShinyADA package. I have some CSS code that sort of encapsulates some of the requirements, naively, piggybacking off some of the Shiny CSS classes that already exist. So just making sure that things that are active are underlined, like I showed before, making sure that there's a minimum font size. In addition, that code for importing Andy, I'm trying to include here. But ultimately, I'd like to have some helper functions that sort of encapsulate the GG pattern package and make adding the patterns to ggplots a little bit easier. And then similarly, I think for complex GT tables, I've found that it's real difficult to get the screen reader to go through it square or cell by cell the way that you'd really like. And so spending some time to sort of make sure that GT tables have at least customizable or some ability to specify how it's read is a goal I have. So yeah, I think that is my last slide.
Carl, we are out of time. Thank you for your great presentation. There are a lot of questions in the chat. Let's do a fast one. Any recommendations for checking whether or not a package is generating ADA compliant code?
I guess the first thing you can do is just sort of put it into a small app and merge in the Andy application and sort of run through it and see if Andy spits out anything obviously wrong from a metadata or a visual perspective. I mean, I think something like the Shiny widgets issue that I identified, if you just kind of put that into a small app and opened Andy, it would pretty quickly tell you, hey, like these inputs don't have a label associated with them. That's gonna be an issue, and you'd spot it pretty quickly. So I definitely would say running things through Andy is a good first step, and then always just inspecting the element in the browser, just take a look. Do you see some aria metadata there? If there's no aria metadata, then maybe it still works. Maybe it doesn't. You gotta really check.
And that's great. That's a great tool, and this is a very important topic. And for sure, we should take it seriously in the community and improve on this field. Thank you, Carl.
Thank you.